Dan McBride of Nawkaw. He's going to be talking about color solutions for concrete. And Dan McBride is the general manager of Nawkaw, Canada, with over 15 years of experience in project management and sales. Dan's formative collegiate experience resulted in a national championship victory for the Wilfrid Laurier University football team, which informed his managerial style of collective effort for collective success. During his time at Nawkaw, Dan has worked tirelessly to provide superior color solutions for concrete and masonry, not only across his home country of Canada, but the entire North American continent from coast to coast. So with that, I will turn it over to Dan. Thank you very much.
Thanks for having me out. Here we go. We're Nawkaw, and we're architectural finishes inspired by art and science, but let's get into the transformational power of concrete stain. Of course, we are an AIA presentation here, and we're protected under all the copyright laws, all that fun stuff. So just that legal jargon getting in here. But so first of all, one of the huge questions we get all the time is, what is paint versus stain? Well, it's pretty simple. Once we get into it, it's all in the bond, really. Paint sits on top of the surface. It traps in all that air, moisture. It doesn't allow permeability or breathability of the substrate. So basically mechanical, meaning it sits on the surface, grabs at whatever it can grab at, and that's what's making the bond. So if you don't have a strong substrate, or if you don't have proper surface prep, paint turns into paint, and it's really, really quick. Anyways, stain. It's a much different bond. It provides a chemical bond, which means that it absorbs into the substrate. It bonds with the substrate on a molecular level. So what you're getting is actually our product, or the mineral-based stain, absorbing, hardening within the substrate by at least within a couple millimeters, and then it locks in that awesome color in there. So as it cures with the substrate, you won't get the different challenges you will with paint. So here we're looking at a view of concrete, right? But two different views. On the left, what you see is concrete with a mineral-based stain, and on the right, what you see is the exact same substrate, but with a latex coating. So the mineral-based stain, the mineral coating, it preserves the natural character of the substrate. And that's like one of the number one reasons architects and engineers love it, because you still get to see the brick, you still get to see the concrete, the substrate that our product's going on, and it doesn't make it look monochromatic. So we get into permeability, and that's the coating breathability. So why is it important? That's a super good question. We get asked all the time. So it's important because all substrates absorb moisture. Okay, what sets mineral-based stains apart from latex coatings is the diffusion of that moisture. So if you see here, like I said, critical when preventing water entering the concrete surfaces. And what you see on the right is a table showing the absorption and diffusion characteristics of both. So absorption, relatively the same. When you look at the top here, what you see is 490 grams per meter squared a day on the latex, and you're looking at about 440 grams per meter squared per day on the mineral-based stain. So, about 50 grams per meter squared per day difference on absorption. That's really not super, there's not a big difference there. Anyways, so diffusion. When you look at diffusion here at 21 degrees, that's what the T equals is, 21 degrees Celsius. Unfortunately, that's up here in Canadian terms. I believe I think that's like 70, 75 in Fahrenheit. Pardon me if I'm wrong, though. But at 21 degrees, a latex only diffuses 95 grams of moisture per meter squared per day, whereas mineral-based stain, 2,100 grams. Very significant difference, right? If that moisture has nowhere to go, guess what? It's blowing out through that latex coating. That's why you see peeling and cracking happen all the time. Then you drop the temperature down to 11 degrees Celsius or 51 degrees Fahrenheit. Oh yeah, sorry, I didn't see it over there. I was right at the 70 degrees. That's nice. Anyway, 51 degrees Fahrenheit, 90% of the moisture in the wall will remain at the end of the day, with the latex, we are diffusing 1,100 grams on the mineral-based stain. So letting all that moisture out of the wall. The more moisture in your substrate, the more damage it's doing. So at the same temperature, mineral stain enables 4 times more water to evaporate than was absorbed. All right, now we're getting into the science behind the staining. And most of the technology that supports mineral stain has been around for a long, long time. But high-quality mineral stains utilize recent developments in color theory with simple chemistry, and they combine all of that with expert applicators, and you can do some pretty cool things. So components of high-quality stains. You got your mineral pigments here, your quartz sand, a silicate binder. That's the most crucial component here. Obviously, it's water-based. And then you got your fillers and then your additives. So quartz. We're gonna go over quartz first here. Quartz sand. It's one of the 2 main ingredients in potassium silicate, and it's also known as silicon dioxide. Quartz sand gets melted down, combined with additives in a silicon binder, and that ensures the stain bonds with the substrate. Okay, the binder, like I said, the most important part. That means the mineral stain is chemically and quite literally a part of the concrete. And we'll get to a little graphic coming up soon, which shows you exactly how far into the concrete we absorb. But it becomes a part of the concrete once the staining process is finished, and it can't be washed off, can't be scrubbed off. You'll literally have to remove the finish of the concrete to remove our product or the product. So, second component, potassium silicate. There's potassium silicate. It's also called water glass, and it's the basis of silicate coatings. It's the principal component of silicate stains and paints. It's been used a heck of a long time, over 100 years for murals and produced from quartz sand, potassium carbonate, and water. So what happens is after that quartz sand, potassium carbonate, and water, it gets heated up and pressurized, and then it becomes this what you see in the top right corner there. It hardens and becomes that water glass. So when the potassium silicate bonds with the substrate after its cure period of 21 days, it actually hardens. Then we got silification. This is what I was talking about before. And so you see in the graphic on the left, we've got the top layer, and that is the hardened agent at 0.1 to 0.3 millimeters. And then we get our substrate penetration of the color up to 2 millimeters. But this is the most crucial stuff that happens with silification. What we got here, yeah, the stain leaves the concrete porous, right? So again, it allows it to breathe. That's a huge, huge advantage over latex coatings. So this is that previous slide here. You see this graphic down in the corner here. This is us overlaying that graphic onto the concrete surface, so you can see how our product binds molecularly with the substrate. So mineral pigments, they're natural inorganic pigments. And so a lot of other pigments in paints, in acrylic products, they are organic pigments. So it's almost like thinking of it versus living versus not living. Like organic pigments, they're going to break down over time. They're going to fade probably naturally with the substrate. You see that a lot with brick, but in concrete, I know you don't get that natural fading as much, but the color will fade with organic pigments over time. But with inorganic pigments, they're light fast. They're UV resistant. So you see the different colors on the left here, and it's just telling you a little bit about how we get those colors, what different pigments we have to use. But again, we're talking about the presence of carbon, again, inorganic versus inorganic, which it ties into how I was explaining it there before, but carbon's found in organic pigments. Inorganic pigments lack carbon in their chemical makeup. So we got surface prep. So it's a little bit, surface prep is probably the most important part of the application process for mineral-based stains. What you want to do is you want to make sure that there is nothing blocking the absorption of the product, right? So preparing the concrete. First, most of all, hot water rinse is usually the first and only step needed for washing the substrate. I know it's counterintuitive to throw water into concrete. We want to avoid introducing more water to the substrate as much as humanly possible. Sometimes some concrete, precast especially, Might just need a light brushing to get all the surface debris off, but regardless, a hot water rinse is often the first step. Then we might get to some light detergents or cleaning agents that are required for certain substrates, or you might need to neutralize a substrate if the pH is off, especially if we have to work with green concrete, which we can. And if anybody has any specific questions, just please message me after the fact on that. And then we are getting into precast concrete, which a lot of times we need a light sandblast or acid wash to remove the wax and release agents. Again, anything that'll block the absorbency of our product or of the product is not good for longevity. So then we got tilt-up concrete. I'm not sure how it is down in the US, but up here, there's only a few players in the game for tilt-up concrete, and every time we come across it, there's always an issue with wax and release agents still being on the substrate. So we have a lot of challenges with that up here. So then we got the staining process. Really no different than the painter's trades of the world, right? We've got brushes, sponges, rollers, rags, splatter techniques as well. And then, of course, the most efficient and quickest and slickest way in the world to do things with sprayers. But with our coloring techniques, we have the ability to play around with the opacity, right? So a lot of potassium silicate stains are manufactured by a few different people, right? And those people as well will manufacture thinning agents to help you take it all the way down to almost where there's only 10% pigment and 90% thinning agent. But they don't disturb the chemical bond, right? They don't mess with the substrate. They just adjust the opacity of the final color. And we can vary, like I said, different levels of opacity to enable applicators to reveal more or less of the substrate, but it gives great control over the final texture. And a lot of times when somebody really, really wants to retain that natural character of the concrete, we thin it way back. And it turns into almost a wash, but then at least you're getting something consistent. A couple of visuals of some other opacities, and these are done with these are actually more metallic pigments, which are pretty cool. We have to use organic pigments on metallics, so we typically have a shorter there's typically a shorter lifespan or warranty on those types of materials, but you can still get a really good vibrant look out of metallics for at least 5 to 10 years. Then we get into color equalization. Now, this is big, especially in the northern states, I bet, and up here in Canada where climate is crazy year-round. And precasters, they're trying to figure out ways to cast year-round, right? The cast-in-place market has taken a huge hit up here. Precast is just blown through the roof, all pun intended. But color equalization is a huge problem for us up here because these people, like we have, like today, actually, for instance, we had an 18-degree temperature swing between 8 in the morning and noon. So you can imagine with the different moistures in the air throughout that time, and then we had frost overnight, like that's a nightmare for these precasters as they're going from pour to pour. So we got correcting concrete, right? It's not perfect, and it's not uncommon for a finished product to look unsightly because of those inconsistencies in cure times. But, there's other reasons. There's construction equipment that mess things up. There's variations in the pouring procedure. There's, a plethora of different reasons why this might happen. But you can utilize a stain to apply a translucent or a fully opaque if you're looking for hiding power, a gray tone onto the surface. And what that does is provides a uniform appearance. So a couple of visuals of befores and afters. This is a veterans memorial and museum in Columbus, Ohio. And this is one of the more interesting aspects of the project that we were actually able to lighten and darker panels as we went. So we didn't have to use the same application techniques or mix for every panel. We could play with it. And that's the way we kept its natural look as best as possible. A good example of pigmented concrete coming out yellow, right? It happens all the time. So stain's able to return the common concrete gray appearance, but it actually intentionally leaves some of the striations and some of the inconsistencies to add more of a texture and help it look natural. Another great example of how we can help some unsightly staining. That was from moisture down there. Sometimes mixes and pours, they go bad for whatever reason, leave lots of inconsistencies, but equalization is still possible if it looks that bad, right? You see a little sample area of a mineral-based stain there. makes it look fantastic. And then on the right, you got the full-size job in its full scope there, completed, looking perfect. Patching. Patching is essential. It happens, right? And there's going to be a ton of it on these precast buildings being erected on site. So patches have to be covered up first, and the final coat of the stain gets applied. But texture is important. You want that texture of the patch to be as close to the mix of the concrete as possible. Yeah, stain does not change the texture, right? If anything, stain will actually accentuate the texture. So if there's a big inconsistency between the two, then you'll still see the patch. Just some more visuals. There's going to be pretty much from here on out, there's going to be a lot of visuals. And I'm in presentation mode, so I can't quite see the chat. So if there's any action in there, Rick, please jump in, cut me off, and let's ask questions in real time, please. All right, so staying in action, like I said, we're about to get visual heavy, but buckle up because these are pretty striking visuals. And some of them you might have noticed from Lane's company, from Lane's presentation, because we have done a lot of great work together for a long time. So here's some metallics that we use on different form liners. Obviously, you got your diamond plate over there. That's a really popular one. But using textured concrete and stain, you can get anything from a nickel-plated look, corrugated metal, whatever it is. Wood looks, brick form liners, stone form liner. It's all good and fun. You see the stone form liners down the side of the highways up here all the time, but they look like the day they were cast, and it's like, hey, why do you go through all the effort of making it look like stone when it just looks like gray, inconsistent concrete? Anyways, if you got the budget and you got the time, we can figure out making it look real with mineral-based stains. Some more examples of brick form liners on the upper left. A nice wood form liner on the upper right with a gloss coating on the after to give it that wet look. Hey, there's that the elephant. There's the elephant in the bottom right corner that Lane was talking about. Hey, this is one of my projects. Hey, I didn't even know this was on here. That's fantastic. This is a great building, 55 Portland Street, downtown Toronto, right in the heart of the city, and directly across from a beautiful park. So it's got a lot of visibility. Anyway, we went in there, and you see that picture on the top left. Mineral-based stain made it look beautiful. This is more precasting, and now you see that nice deep red. That's using the organic pigments. A lot of times you have to use organic pigments to get deep, deep reds, deep yellows, and super deep blacks. With inorganic pigments, it's hard to get very deep black and deep red. Parking structures, this is becoming big, working on parking garages, large concrete structures, right? And by design, the stain can add accent to elements such as the matte black finish, right? It doesn't have to be glossy all the time. It doesn't have to be formed all the time, but using matte or gloss finishes help take smooth concrete or light sandblasted concrete and give it a different twist. Again, wood form liner, right? It's really, really cool look. Everybody loves those natural looking substrates, right? But nobody likes replacing them after 5 years. So mineral-based stains have the ability using layering techniques. A lot of times you'd be rolling on a base color and then feathering with sponges and brushes, those different accent colors. A lot of time and energy put into this, but well worth it for the finished project when you look on the right there. And here's some before and afters of that project in real time there. Beautiful precast building though. Some more wood form liners. That's the same project as well. Get that tiled wood look. It's a really good example of cladding, right? It's an alternative to cladding. This is a really cool project. There's a lot of mineral-based stain applications in Australia because of the salt content in the air on those coastal cities. It's very resilient to that compared to different latex coatings and even other acrylics and whatever, different types of coatings. But these colored textured panels on the side of the building, they're originally gray precast, but after we colored it in with earthy tones, it matches its surrounding environment. It kind of blends in. It's nice. Just another good example of how you can make precast look like that architectural precast look like cladding. That's a brick form on the right. A lot of times you're leaving those mortar joints, that natural gray cast color, and then just rolling over the brick faces, which makes application super easy because you can use those 16, 18-inch foam rollers and just go right over the top of it without having to worry about the mortar joints. Here's a really cool one, vibrant, really vibrant. Another one from Australia, like just super bold out there. It's a great example of how you can take outside the box design architectural ideas and transform it into these really vibrant, striking finishes. This is an example of our metallic product. Believe it or not, this is not photoshopped. All three of those buildings in the forefront there with the Lego or the Tetris shapes, the white one in the middle, and that tan beige one on the right, those are all precast concrete projects using mineral-based stain. And, many national storefronts and chains need to utilize standardizes colors. And, a lot of times people just want to, these places, they don't want to throw latex coatings, paint on the building. So they come to mineral-based stains because of their longevity, their durability, and the ability to go over them again without having to remove the latex prior. This is Ontario, Canada, if anybody's familiar with the territory. But this is the first tilt-up concrete house ever built in Canada. So this is a cool mineral stain project. You see there's a mixture of a lot of different forms. You got brick, stone, and wood. And there's also some smooth in there, but a lot of different finishes. It looked fantastic when it was done. A nice, beautiful country home. So a good example of precast concrete that can be developed into a believable masonry finish, right? With the layering of colors with masonry, with potassium or with mineral-based stains, you can layer multiple colors, right? You can apply that color probably 4 or 5 times in at most a 50% opacity before it starts to build up on itself and look like a film-forming finish. So with that, you're able to layer on 3, 4 different colors to make it give it a natural range. So choosing colors and finishes, it's a pretty cool little process. A lot of times there's mineral-based stains are able to show you examples, right? If you got a building that you're looking to retrofit or a adaptable reuse or something like that, then there's people out there that can come and show you exactly the transformational powers of stain. So I know this is a brick and mortar project, not quite concrete, but it helps give you an idea of how that sample process happens. You see on the bottom left, a technician went out and did a sample with the mineral-based stain. It was based on a presentation board that the customer had given. Right, there's during down there, you're working your way through, and there's the final product. Looks fantastic, you wouldn't know. So this is a concrete brick. So Photocatalytic Systems. This is an emerging, absolutely amazing product on the market. And what it is so forgive me because I'm going to read here because this is a lot of science. I'm going to go straight from my notes. So photocatalytic systems, they're activated from light, and they begin chemical reactions on the applied surfaces that kill viruses and bacteria. They release oxygen into the air, and they ensure dirt and debris don't stick to the surface. So the photocatalysis is the power of the sun. So essentially, it's a chemical reaction accelerated by light. So when light from the sun or even artificial sources strike the titanium dioxide in photocatalytic coatings, titanium dioxide pulls water molecules towards itself and away from the substrate. So on exterior surfaces, when it rains, the water just runs off the surface and it carries along with it the contaminants, the dirt, the debris. It takes it all down the wall with it and essentially cleans itself. So we call it a self-cleaning coating. Chemical reactions also release oxygen into the air and simultaneously destroys bacteria, viruses, and fungi in contact with the process as well. So essentially, what that's saying is it's an air purifying system as well. All right, so that gets us to the end here. I was quick and slick there. I hope everyone's all right with that.
Yeah, no, but that's great. But no, that was great information, Dan. I really appreciate you being willing to share with us.